Okay, good morning, afternoon, or evening. How y'all doing today? Today we're going to talk about 2.8, solving inequalities with one variable. The good news, there's not many differences, okay, between inequalities and equations. In fact, there's only one difference, and we're going to get into this with detail, but basically the difference is when I divide by a negative or multiply by a negative, I'm going to flip, exactly, I'm going to flip the inequality sign. Someone was making a little symbol there. You're going to flip the inequality sign, okay? That's the only difference. Now, there are some other differences in the way we express our answers, okay? In equations, we're going to use equal signs. With inequalities, we're going to use inequality signs. So equations use equal signs, okay? Inequalities use what's called inequality signs. What are the inequality signs? Very simple. Less than, straight up, it's just less than. That's it. Greater than, it's greater than. Okay, now, how to read this? Sometimes people don't understand. They see the symbol and they say, okay, that's great, but how does it really work? Well, let's just say that I tell you, I give you the following. Okay? You always read from the variable. Always. So this would be x is less than 8. I know you guys aren't in elementary school, but remember the alligator. Okay? The alligator eats the bigger number. Okay? It's not really a great way to think about it when we get more complicated. But for now, just to kind of remind you, remember the larger number is being eaten by the alligator. So in this case, you read from the variable x is less than 8. Okay? X is less than 8. You go from the variable. I don't care if they invert it. A lot of people are going to be tempted to say 8 is greater than x, which is technically correct, but that's extremely difficult to work with when you're actually dealing with more complicated inequalities. So regardless, you always read from the variable. So in this case, again, x is less than 8. Okay? Does that make sense, guys? Just if I say x is greater than 8, or if I do it like this, I read from the variable x is greater than 8. Okay? Less than or equal to, it's pretty self-explanatory, same properties, but it's got this little line underneath. That means that it's greater than or equal to. Okay? Greater than or equal to. I'm sorry, less than or equal to. Greater than or equal to is with the greater than sign. So less than or equal to and greater than or equal to is same as less than or greater than. You just have a little line underneath the inequality sign. And not equal to, pretty self-explanatory, an equal sign with a little slash through it. That's not equal to. Okay. A couple things that a lot of people mess up on a lot, and I think it's because a lot of books and teachers don't actually teach this. When dealing with word problems, okay, because we're going to have word problems. That's going to be part of our life throughout this whole class. When dealing with word problems, remember the following. When they say at most, they're talking about less than or equal to. Okay? It's kind of reversed. It's at most, but we're talking about less than or equal to. When we're talking about at least, it's reversed. You're thinking about the smallest, but it's really greater than or equal to. Let me explain how this works and how to identify when you have an inequality, okay? It says here, moral is at most 40. First of all, what does is mean, guys? Equals, right? Okay, so look, whenever you have an is, that activates the inequality sign. Let me explain what I mean. X X more than 5. That would just mean X plus 5. Okay? You with me? But if I tell you X is more than 5. That is more than, it's like saying is greater than. That is there activates the inequality. So in that case, it would be X is more than, greater than 5. So whenever you have that is, it's either talking about an equation, an equal sign, or an inequality. That is activates the equation basically. So if I say x is greater than 7, that's x is greater than 7. That's an inequality sign. Does that make sense, guys? Because a lot of times people get confused with that. That is really, really, really important. So, okay. So moral is at most 40. Think about that. That means that moral is 40 or less. I'm at most 40. So that means I'm 40 years or younger. Does that make sense, guys, in your head? So whenever we're talking about at most, we're talking about less than or equal. Now, at least, that reverses as well. You're thinking it's small, but it's really greater than or equal to. For example, moral is, activation there is, that's the activation. Moral is at least 40. Okay? At least 40. That means that his max, that his minimum is 40, and he goes older than that. Does that make sense, guys? You guys here in the room, you are at least 14. You're at least 14. That means you're 14 or older. You guys are at most probably 15. You're 15 or less. Does that make sense, guys? Have you ever been taught about the at most or the at least thing? Okay, good. For those of you that haven't, now you know. Okay. Now, before we get into the actual inequalities, there's still a few things, a few pointers I got to go over with you guys. Let's talk about what a set builder is. We're going to talk about set building, and we're going to talk about interval notation. And when we're talking about set building, okay, that's the basic way of writing inequality solutions. And it's going to be something like this. You're going to have this braces here, and you're going to have the variable that you're dealing with. If you're dealing with x, you're going to have an x here, and you're going to draw a straight line. That is just telling the reader, hey, reader, the solution I'm about to give you is dealing with x, bro. It's not dealing with y or with z or with w or with q. It's dealing with x, okay? And this x value, the solution of this x value is this. Let's just say, for example, x is less than 5. That's the solution set, okay? That's how you do a set builder, solution set builder. This is the basic way you do it. So at the end of your equation, you get the following answer. X is greater than 3.2. I'm going to ask you to put that into both set builder and interval notation. Set builder, you go braces, the variable you're solving for, straight line down, x is greater than 3.2. Any mathematician in the world can read that. Does that make sense, gentlemen? Okay, so let's just do a couple set builders here, okay? Write each solution using set builder notation. So x is less than 5. So I do a little brace. X is the variable I'm solving for. Straight line. X is less than 5. Done. Just out of curiosity, what would be some valid values for this solution? Yes, sir. 4, 3, 2, 1, 0, exactly. Anything less than 5. Would 5 be a solution set here, gentlemen? No, because x is less than. Awesome. Okay, x is greater than or equal to -2. Again, I'm not trying to bore you, so let's get through it. Braces, x, straight line. The definition of the solution, x is greater than -2. Close with a brace. Is -2 a solution in this case, gentlemen? Yes, very good. X is greater than 3. Braces, definition of the variable I'm solving for. Straight line, the actual solution, x is greater than 3. Bam, done. Does that make sense, guys? Pretty simple, right? That pretty much is what you've been doing your whole life, except they usually let you keep it like this, correct? Right? Okay, good. So the only thing that we really added here, guys, if you really think about this, the only thing we really added was this part here, right? That's the new part. The braces and the x and that line defining it. That's it. Okay, so nothing new there. May I continue? Awesome. Okay, guys, now, interval notation. Are you ready to grow a little bit today in math? Because today, hopefully, some of you have never seen this, and for those of you who have seen this but have been a little confused, hopefully today we're going to really make it solid for you and really make it easy and understandable. This is the way the big boys express their solutions, guys, and the big ladies out there. There's a lot of brilliant mathematicians that are women. Interval notation. Look at the way I said it. It's a fancy way. It's a fancy way of writing inequality solutions. Not only is it fancy, but it's really the mathematical way. That is the professional way. If we were engineers or architects or stuff like that, we'd be using interval notation. We're not going to use set builder. Set builder is a little bit elementary for the higher mathematics. This is quicker. This is easier. And I'll show you how it works right now. When dealing with less than or greater than, straight up, guys, just so you know, you're going to use parentheses. Always. If you're dealing with a less than or a greater than, you're dealing with parentheses. Parentheses basically lets the reader know, hey, dude, this number's not included. It's everything else. Okay? When dealing with less than or equal to or greater than or equal to, you're going to use brackets, guys. Brackets let the reader know, hey, dude or dudette, this value is included, and then everything else. Okay? So greater than or less than, parentheses, greater than or equal to or less than or equal to, brackets. Okay? Now, look at this guy right here. You always use parentheses for infinity. I have a plus or minus infinity here. That just means negative infinity, not 8. Negative infinity or positive infinity. Whenever we're dealing with infinity, we are using parentheses. Now, the question may be, why, Mr. Morrow? What if it says x is greater than or equal to infinity? I can't, you mean to tell me, Mr. Morrow, that I can't use a bracket? You said greater than or equal to. Yeah. When I have a parentheses, an infinity, it has to be parentheses because infinity has no definite end. Infinity goes on forever. So can I ever really lock in place one value and stop that value with a bracket? Does that question make sense, what I just asked, guys? Can I do that? Can I stop something that never ends? No. So since I cannot stop infinity, I cannot locate one particular spot that, hey, that's infinity. It goes on forever on both sides. It has to be parentheses, okay? Now, when you're using interval notation, please remember that the format is always the smaller value, comma, a larger value. That will not change. You're never going to have the larger value first and then the smaller value, ever. You're always going to have smaller value, comma, larger value. For example, write each solution using interval notation. All right, guys. You guys remember how to graph these bad boys? Okay. I'm going to show you the key to the city here. What I always did when I was a kid, I didn't really understand this very well. So what I used to do to help myself is I'd make a little sketch of the graph. And then I would see the actual solutions right in front of me. And then for me personally, it was a lot easier to write the interval solution. So real quick, I'm going to sketch x is less than 5. X is less than 5. Remember, we're using a less than. So am I going to use a parenthesis or a bracket? Okay. I always put my 0 to have a reference point. Here's my 5. And I'm going to have x is less than 5. So is it going to be to the left of 5 or to the right of 5? Okay. So I put a parenthesis at my 5. That tells me, hey, reader, 5 is where it stops, but it is not included. 5 is not included, but everything to the left is. Does that little Mickey Mouse part make sense? Okay, now, from there, guys, when I keep going to the left on the negative side, don't I approach eventually negative infinity? So aren't the solutions to this everything from negative infinity, the smaller value first, comma, to 5, the larger value, but 5 is not included, so I encapsulate that with a parentheses. I saw some people go, oh, wow. Talk to me, guys. This is important, and I need you to be honest. Thank you. Yes, sir. Would there be a parenthesis and a bracket? Absolutely. What if I told you this? X is less than or equal to negative 3. Well, here's my 0. Here's my negative 3. X is less than or equal to. So, hold up. Come on, Moral. Bracket, right? And it's everything to the left, correct? When I'm going to the left and I'm going further and further negative, am I not going negative infinity to comma negative 3 with a bracket because 3 is included? Does that make sense? Yes, sir.
In my math class, when I was in 8th grade, we used circles.
Okay, circles, and brackets. Okay. When you have less than or greater than, you used to use circles. Now you use parentheses. For less than or equal to or greater than or equal to, you used to use a solid circle, but now you're using brackets. Oh, thank you. Great question. Valid. Sir. Yes, guys, let me go through some examples before you throw every single situation at me. Give me 1 second. Because everyone sees so far how I do it when you have a less than value. You're going from a negative infinity to that number.
So when it's not included, it's parentheses.
Less than or greater than is not included. So that is a parenthesis. Less than or equal to or greater than or equal to is included, and that's a bracket. Does that make sense, gentlemen? Okay, thank you. Now, I'm going to erase this. Can I? Okay. Now, x is greater than or equal to 2. Let's make a little quick sketch. 0, negative 2. I know I'm going greater, so I'm going to the right. Do I have a bracket or a brace or a parentheses? Bracket. Now, guys, what's the smaller value here? So I go bracket. Hold on, let me do that nicer. Bracket, negative 2, because that's my smaller value. 2, what's my larger value here? Infinity, positive infinity. Parentheses, because infinities always have a parentheses. Yes, sir, my brother. Yes, positive infinity if you're going to the right, negative infinity if you're going from the left. Yeah. Okay, let me repeat myself. Positive infinity when you're going positive. Negative infinity when you're coming from the negative. Yes, you need the positive and the negative sign. Thank you, sir. Okay, does that make sense, guys? How about x is great? Yes, sir. Okay, okay. Let's review. This is the solution, son. But I'm going to ask you, and professional mathematicians are going to ask you, and the SAT and the ACT and all of these tests are going to ask you sometimes to write it in interval notation. X is greater than or equal to negative 2 is read right here. The values that are valid for this solution are equal to negative 2 and anything greater than that. So it goes from negative 2 to positive infinity. All of those are solutions. Do you see how the graph matches up with the interval? And the solution matches up with the graph? Does that make sense, son? Thank you. X is greater than 3. That's the solution. Graph it. Mark your 0. Here's your 3. It's greater than, so I'm going to the right. Am I going to use a bracket or a parenthesis? A parenthesis. What's my smallest value here? Parentheses 3. Why parentheses? Because it's not included. Comma. What's my largest value here? Positive infinity. Parentheses, because infinities never have brackets. Does that make sense, guys? These are good questions. Thank you for your honesty. Yes, sir, my brother.
Why is it that in... Oh, no,
Okay? May I continue? Yes, sir, my brother? Okay. Now, we're going to go through graphing a little bit more detailed now, but we pretty much already did it. I should have actually put this first. Sorry about that. Graphing inequalities. When graphing inequalities, remember, when dealing with less than or greater than, you use braces. You used to use circles. When you have less than or equal to or greater than or equal to, you use bracket. And I'm sorry, you don't use braces. These are not called braces. They're called parentheses. Come on, Moral. Parentheses. Use the right vocabulary. When it's less than or equal to or greater than or equal to, you use brackets. You used to use a filled-in circle. Okay? Remember, always use parentheses for positive or negative infinity. All right, let's just graph these. We don't even have to put these in interval notation, but you know what? We will, just for giggles, okay? Extra practice. So let's graph it. So I've got my 0 as a reference point. I've got a 5. I'm going less than. So is that left or right? Okay, I'm going to go to the left with a parentheses or a bracket? Parentheses, and I shade everything to the left. Does everyone get that part? How do I write this in interval notation? Sir?
Well,
Parentheses, good man. Negative infinity. Comma. 5. Beautiful, son. Well done. Well done. X is greater than or equal to negative 2. Make my 0 as a reference, my negative 2. Am I going to go to the left or to the right of that? Yes, sir. To the right. Awesome. Am I going to use a parenthesis or a bracket? Bracket, because it's greater than or equal to. Bracket. Shade to the right. Okay, what's my interval notation here? No, not negative 2. You first have to put a symbol there. Bracket. Negative 2, my smaller value, to positive infinity, my largest value, and with a bracket, right? Good catch, guys. It's not a bracket. Come on, Mr. Morrow. It's a parenthesis. Good job. X is greater than 3. Mark my 0 as a reference point. Here's my 3. Am I going to the left or right? To the right. Parentheses or bracket? Parentheses. And I go to the right. What's my interval notation here, gentlemen? Parentheses. 3. Comma. Positive infinity. Oh, yeah. And then I close it with a parentheses. Yes. X is less than 4. Mark my 0 as a reference point, my negative 4. Am I going to the left or right from negative 4? To the left. Parentheses or bracket. Parentheses shaded to the left. What's my interval notation here, please? Parentheses. Negative infinity. Comma. Negative 4. Parentheses. Please remember, you're always going from small to large. I heard someone say out there negative 4 was the first one. No. I'm going from way out here into negative infinity land, and I'm going all the way to negative 4. Those are my valid solutions. Does that make sense, my brothers? You promise? May I continue? Okay. Now. In order to solve inequalities, simply use the same procedures for solving equations, except the following. Whenever you multiply or divide by a negative, you must flip the inequality sign. Let me explain what multiply or divide by means. Because there's a difference to multiply by and to multiply to. Big difference. If I have this, for example, negative 2x is less than 4. I'm going to divide by a negative 2, correct, guys? So since I divided by a negative 2, I'm going to get x is greater than negative 2 now. Because I divided by a negative 2. So what happens? I got to flip the inequality. So if I divide or multiply by a negative, I flip it. Now, what happens if I multiply or divide to a negative? Nothing. If I have 2x is less than negative 4, what am I dividing by? Do I flip the inequality sign here? No. So I only flip the inequality sign when I'm multiplying or dividing by a negative. If the number you're multiplying or dividing is negative, then you flip the inequality sign. If the number you're multiplying or dividing is not negative, you do not flip the inequality sign. You with me, guys? Okay. Now, real quick, I was just thinking I have a bunch of time left. Real quick, let's go back for just 2 seconds. I want to make sure that this interval notation is really, really good, okay? What if I give you this? What if I say, these are my solutions? How would I write that as a set builder? What's happening here? Yes, sir. No, we always read from the variable.
X is greater than greater than 2.
Perfect. X is greater than 2. For those of you who couldn't see it, sorry about that, guys. Our ears got assaulted. Okay. 2 comma infinity. What happens there is X is greater than 2. But sometimes people don't see it. Graph it, boys. Okay, what is going on here? I have this 2 with the parentheses, and it's going to infinity. If you draw it out, with some of you, would you see the connection to this a little bit easier? Then I want you to draw it out. Always draw it out. That's going to help you guys out, okay? Yes, sir, my brother. So it's the exact same method that I'm using. Draw it. Yeah, draw it out. What if I had this, guys? Okay, let's use our brains now here for a second. 3 comma 8. Let's draw it out, okay? We got our 0, we got our 3, and we got our 8. What's happening here? Yes, sir. Right, so the solutions are between 3 and 8, aren't they? How would I write that as an inequality? Yes. X is greater than 3.
And X is less than 8.
And less than 8. And that's called a compound. Does that make sense, guys? Making these connections here, my brothers? Okay? You promise? So now let's reverse it. Let's reverse it. Let's say I had X is greater than negative 2, but less than or equal to 5. Graph it, graph it, graph it before you turn it into interval notation. It's going to make your life easy. Here's my 0, here's my negative 2, here's my 5. Parentheses on the 2 because it's greater than. I'm going that way, greater than. Oh, wait a second, I got to stop with a bracket at 5 because it's less than 5. X is between negative 2 and 5. Interval notation, it's pretty much written there for you. Negative 2 to 5 with a bracket. Talk to me, sir.
Can we change the building notation to 4 and the
Come again?
number 4?
Number 4. This is inequality already. And then I have the graph, and then I have the interval notation.
Oh, so it was already there.
Yes, sir. Okay. Does that make sense, guys? Yes, sir. Of course, son. Which way do you want me to do it? Going from interval to, or both ways, everything. Okay. What if I give you this, bro? I want you to write this in set builder. Negative 3 comma 5 parentheses. First thing I'm going to do is graph this. Here's my 0, here's my negative 3, here's my 5. I got a parentheses on 3 because 3 is greater, 5 is greater than negative 3, so I got to go this way to 5, but the x value is either equal to 5 or less than it, so it's between. So now that I have this here, it's pretty much written for me in interval notation. You've got negative 3 comma 5 with a bracket. What if I told you, and hello, I wanted to write this in set builder. So braces, x, line. Okay, x is greater than negative 3, but less than or equal to 5. That make sense, kid? No, thank you, son. What if I told you x was greater than 6, but less than or equal to, I don't know, 15? Graph it. Here's my 0, here's my 6, here's my 15. X is x is greater. Remember, always read from the variable. X is greater than x, parentheses, than 6, and less than or equal to 15, bracket. It's everything in between. So I've got parentheses 6, comma 15 with a bracket. Does that make sense, guys? Thank you for your honesty. Anything else on this, guys? I don't want this to be a problem for you later. I do not want it to be. Sir? Yeah, this is saying it's going from smallest value to largest value. And in this case, it's everything in between. That's why I like doing all three sometimes, especially the graph. The graph lets you know what's going on. The graph clearly tells you that the values for this solution are between 6 and 15. 6 is not a solution, but 15 could be. Anything in between could be as well. That's a great question. Thank you. Anything else, gentlemen? Yes, sir.
What would you describe equation like x is less than 6?
X is less than 6, but x is greater than 15. Okay, we just did that. But okay, here's 0, here's 6, and here's 15. Oh, okay, this is a little different. Thank you. No, this is great. This is great. Thank you. X is less than 6, so it's going this way, correct? And x is greater than 15, so it's going this way, right? Actually, that's a spectacular question. This is going to be a compound again, but it's a union. What's happening on this side over here? What's the smallest value, guys? Negative infinity all the way to 6, but 6 is not included. You with me? Now you put a U here. That means a union. So you have that in union with, what's my smallest value on this side? 15. And I'm going all the way to positive infinity. Spectacular question. Fantastic question. I'm glad you asked it. Great. Does that make sense, boys? You understand this? All right, now let's solve some equations. May I? Okay, it's on a video, so you can hit pause. Okay, now, let's move on. So I got some equations here. Some are easy, some are more difficult. Use the same skills that we learned for equations, please. So how do we solve for number 1? Negative 2 is being multiplied to x, divide by negative 2, but I'm dividing by a negative. So I got to flip, thank you, so x is greater than 5. I'm always going to ask you for the inequality, the graph, and the interval until you've mastered this. So x is greater than 5, here's my 0, here's my 5, parentheses to the right, interval notation, small value 5 to positive infinity, which is my large value. The set builder requirement, the graph, the interval notation. Does that make sense? I divided by a negative, so I flipped the inequality. Okay, number 2. Oh, it looks so ugly. Not so bad actually at all. Okay. What do we do here when I have fractions? What do we learn? Multiply the LCM. That is exactly correct, sir. To everything. Okay. So 15 times 4 is 60, right? Divided by 3 is 20x. 15 times negative 2 is negative 30. Divided by 3 is negative 10. That's less than or equal to. 15 times 4 is 60. Divided by 5, that's 12x. 15 times 3 is 45. Divided by 9 is plus 9. Now, we don't have any distributive property to do. Okay, so we don't have any terms that we can combine. So we're going to move everything to the variables to one side. Subtract 12x to both sides. I got 8x minus 10 is less than or equal to 9. Oh, this one came out ugly, but it is what it is. So I add 10 to both sides. So I have 8x equals 19. Divide 8 to both sides. I'm sorry, less than or equal to. And x is less than or equal to 3. No, not 3. 2. 2 and 3/8. Okay? Now, I want to graph it, and then I want to interval notation it. I'm gonna erase the work. I hope you have it. Okay, let's graph it. Very simple. Here's my 0. We could say that's 2 and 3/8. I'm going less than or equal to, so I've got a bracket shaded to the left. My interval notation, my smallest value here is negative infinity, and I'm going to 2 and 3/8. Bam. Oh, what did I do wrong there? Bracket. Negative infinity, comma 2 and 3/8, bracket. Does that make sense, guys? Awesome. Thank you. Okay. No, I can't go back because it's a video, and you have the ability to hit pause. Okay. Here, I gotta move all variables to one side. So I'm gonna subtract 5x to both sides. I got negative 3, and then I got a negative x. I always want to solve for positive x in the numerator, so I divide by a negative 1. So x is greater than 3. I got to flip that bad boy. So the graph for this, here's my 0, here's my 3, parentheses shaded to the right because it's greater than, interval notation, parentheses 3, small value, to infinity, parentheses, because that is my large value. Okay, 3 more. Number 4. First, what do I have to do first here, gentlemen? Distribute. Thank you very much. So I'm going to multiply. It's going to be 12x minus 24 plus 12 is greater than 11x minus 13. Combine like terms on both sides. 12x minus 12 is greater than 11x minus 13. Get the variables on one side. Subtract 11x to both sides. I have x minus 12 is greater than negative 13. I have a one-step equation here. I undo subtraction with addition. So I add 12 to both sides. And I get x is greater than negative 1. X is greater than negative 1. Okay? For number 4, the graph would be 0, negative 1. X is greater than negative 1, parentheses, shaded to the right. Interval notation, small value in parentheses because it's a greater than, to the larger value of infinity, parentheses, because infinities always use parentheses. Does that make sense, boys? Okay. Number 5, we got a Mickey Mouse one here. 6y is greater than negative 42. Divide by 6 to both sides. So y is less than negative 7, right? Okay, you guys aren't even paying attention. Why would I flip that? That is not yeah. You should have said no, Mr. Morrow. Did I divide by a negative or to a negative? Ah, do I flip the sign when I divide to a negative? No. So this is just going to be y is greater than negative 7. Here's my 0. Here's my negative 7. Greater than, parentheses, shaded to the right. My interval notation, my small value negative 7 to my large value of positive infinity. Done. Make sense? Okay, and last but not least, how did I teach you guys to get rid of fractions really easily, quickly, in one step? Reciprocal, thank you. So you're going to multiply both sides by negative 3 over 4. You're going to multiply both sides by negative 3 over 4. So those cancel, and I got x is, what happens here since I divided by a negative? Got to flip the inequality, so it's greater than or equal to. The 4's cancel. Negative times a negative is a positive. I got 3/5. Graph, here's my 0. Here's my 1. Here's my 3/5 in here. I've got a bracket. Everything shaded to the right. My interval notation is right there from the graph. You can see it right there easily. Bracket, 3/5 is my smallest value, to comma, positive infinity is my largest value. Does that make sense, boys? Awesome. Thank you very much. Hope you learned a lot. Have a great day.